Hey everybody, welcome. Let's go ahead and get started. We are going to be doing the Unit 5 Study Guide. So let's jump in. First thing, we cross multiply for our proportions. Again, proportions just two ratios set equal to each other. So we cross multiply 2 times 15 is 30, and 3x, divide by 3, x equals 10. On these, we have to make sure we distribute, so it's going to be 3 times 7, which is 21, and then sometimes it's a good idea just to write it out. And we distribute the 2, and we get 21 equals 2x plus 4. We're going to subtract the 4 on both sides to get that to become, I think that's going to be, what, 17 equals 2x. And then from there, we're going to go ahead and divide by 2, and we should get a value of about 8.5 for x. Will you see decimals on the test? Yes, they will be there. Fear not if you get one. All right, cross multiply. 12 times 15 is going to give you a decently large number of 180, and then we're going to have to FOIL. So this is where I have to go first, inner, outer, last. So x times x is going to give you x squared. X times negative 7 is negative 7x. 4 times x, and 4 times negative 7, which should be 28. Negative. Okay. And then we have to combine like terms, and I'm also going to subtract the 180 over at the same time. So this should be set equal to 0, x squared. We're going to combine 7x and 4x to give me negative 3x, and negative 28, and then the negative 180 I subtracted over is going to give me negative 208. So from there I just have to factor, and what two numbers multiply to negative 208 and add to negative 3, and 208, if you divide it by 13 or 16, you should get the values. Obviously one's positive, one is negative. The 16 here is negative, so we get x minus 16 and x plus 13 equals 0, so set them each equal to 0, which basically will just result in x equals 16 and negative 13 as your answers. Okay? If you're struggling here, just take 208 and go through and divide it by values that you think would work. Since we have to add up to 3, you probably think the numbers are pretty big, so maybe you don't start at 2, start with 4. 4 and 52 won't work. Try 6. No, that doesn't go in evenly. Try 8. 8 and 26, you're getting closer. So you just slowly build up until you get to the value that works. And then that's kind of the basic strategy there. Yes, it could take time with those bigger values, but you have to make the right steps in order to get there. So, yeah, there we go. Next, we have two complementary angles are in the ratio of 7 to 11. So this is extended ratio, so we just do 7x plus 11x equals, and our key word here is complementary, which means we should add to 90. So that's 18x equals 90, and 90 divided by 18 is x equals 5. And then it does say the smaller, 7 is smaller, so we're going to do 7 times 5, which gives me 35 degrees. This is the ratio of angles, so we're going to do all of them again. 8x plus 3x plus 4x equals, and this is going to be 180, which is the degrees of a triangle. So we add 8 plus 4 plus 3, and we get 15x equals 180, and then divide 180 by 15, and we get x equals 12. Find the largest angle, so I'm going to plug it back into 8, so 8 times 12 is going to give me 96 degrees. The ratio of the sides of a triangle, so I don't want to add these up and set equal to 180, I want to add it up and set equal to the perimeter, which means they have to give it to me. And here I can see the perimeter is 130, and so I'm going to do 9 plus 12 plus 5 is going to give me 26x equals 130. I'm going to divide by 26 and get x equals 5, and it says find the shortest side, which would be 5, and so we're going to do 5 times 5, which is going to give me 25 feet. I believe it was in feet. Write the ratio of the first measure to the second measure. Make sure your units are the same. Well, this is in inches, so I got to multiply this by 12 inches. So that's going to give me 18 inches is the same as 1.5 feet. So I just have to go 2 to 18, but that reduces to 1/9. Same unit of measure for that ratio. Alrighty, on the back. Dilation. So dilation is just multiplying the point by a scale factor. So I really just have to distribute this 5/7. You can do it in your calculator, pretty easy, 14 times. And they have this little fraction bar, 5/7, and you can get your value of 10 that way. Or another way to do it, if you don't have this type of calculator, you can take -7 and just multiply by 5 and divide by 7. Right, that's the same thing. Multiplying by the top number, divide by the bottom number, and that one gives you -5. So pretty simple. Just multiply. You're done. Graph the image of the quadrilateral RST after a dilation of a scale factor of 2. Okay, so what I like to do is I like to write the original points, RSUT, and then I just double them. So this is going to be 1, 2. U is 1, 0. S is going to be 1, 2, 3. And T is going to be 1, 2, 3, 0. So just all we have to do is basically multiply by 2, and so we're going to get 2, 4, 4, 6, 2, 0, and 6, 0. And then we just go ahead and plot those points. Let's see, so R prime is at 2, 1, 2, 3, 4. There's R prime. U is going to be at 2, 0. There's U prime. S is at 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. There's S prime. And that's going to be at 1, 2, 3, 4, 5, 6. T prime. And there's my shape. Again, the shape should look the same, just larger. P or Q is dilated to create P prime, R prime, Q prime. What scale factor was used to dilate the image? So here's my new size, which is 1, 2, 3, 4, 5, 6 units long. And here's my old size, which is 2 units long. I'm assuming that's going to be, it's increasing by 3. But we can take a point and look. So like, what is P? P's at 1, 3. And then what's P prime? That's at 3, 9. And like, how'd I get from here to here and here to here? And that was probably multiplied by 3. So my scale factor from here to here is probably 3 to 1. Or 3 is my scale factor. You could say K equals 3 would be also sufficient. Find the scale factor from A to B. So here we just have to pick one side. I'm going to go small to small. And so I just get 25.2 over 14. Remember, I'm going A to B. That's really important. I do 25.2 on top. And I just throw in my calculator, reduce the fraction to get 9/5. And on the next one, again, find the smallest piece, which is 12 and 9. And now it's B to A, so I'm going to put B to A. So I'm going to put 9 on top, 12 on the bottom. And we could reduce this fraction pretty easily. 3 goes into both, so that's 3/4. Again, make sure you read this part on how it's asking you to set up the ratio. A to B, B to A. Okay. Should have got some water. How many we got? Oh, we got a lot. All right, almost halfway. Polygons are similar. Find the values of the variables. So we want to match things up. So here I see X is matching up with 9. I see 4 is matching up with 6. And that's going to be important. And then we also see Y is matching up with 12. And I'm going to use those ones. I do have to set up a proportion to solve because they're not congruent. So I'm going to go left to right for setting these up. So I'm going to go X over 9 equals, and then I need values that don't have any other variables. So I'm going to do the 4 and the 6. And then you could do a second equation with the y's. That's y over 12 equals, and I'm going to use the 4 over 6 again because, again, I need 4 values in my proportion, and only one of them could be a variable. So cross multiply, we get 6x equals 9 times 4, which is 36. divide by 6, x equals 6. 12 times 4 is 48, equals 6y, and divide that by 6, y equals 8. Okay? Now this one, again, I would like to highlight, this is coming off of the double, so this matches with this guy. You know that this matches with this, and then the only thing left is the 9 and the 15 match each other. So again, I'm going to go left to right to keep myself consistent. I like to set up that. I'm going to go b over 10, and then I need to use the 9 over 15. And then I'm going to do it again. This time I'm going to go a over 12 equals 9 over 15. Just keeping it consistent. Now my a's and my 9's look the same, but that's an a. I'll put a little curvy on it. And my b's are not very good either. There we go. We get 15b equals 90. 90 goes into 15, or 15 goes into 90 about 6 times. Over here we get 12 times 9, which is going to be, is that 108? I'm just going to double check. Yep. And I don't think that goes in evenly. It doesn't. But we get a is equal to about 7.2. And again, decimals are okay. Our triangles are similar. Solve for the scale factor, find x and y. Basically, we're doing the same thing. It just asks for a scale factor. So we want to line up, like, what does 20 line up with? That's ED. I don't want to guess. I can't go off of what's the smallest because I don't know x and y, but I do have the similarity statement. So ED matches up with AB. So I know those two are the pieces. And it says scale factor from this triangle to this triangle, so I'm going to go from here to here. So my scale factor should be 36 over 20, which will reduce to 9 over 5. So that's my scale factor. Now I can set up my other pieces. FD, if I look here, FD, that should be AC. And then the last one is obviously going to be right here. And then we just set up two proportions like we did on the last one. So this is going to go, I'm going to go from here to here. So 27 over x equals, I can use 9 to 5 because that's the same thing as really 36 over 20, it's just smaller values. And then I got 25.2 over y equals 9 over 5. So cross multiply, we get 9x equals 27 times 5, which is 135, and then divide that by 9, and we get x equals 15. Over here, we get 9y equals 25.2 times 5, which is 127.5, and then divide that by 9, and we're going to get 14.16 repeating, which is, again, okay. All right, 16, at a certain time of the day, a 1.8 meter tall person, so we got a person right here, that was a weird looking person, is 1.8. Standing next to the Washington Monument, here's the Washington Monument, it's like a tall obelisk looking thing, cast a shadow. At the same time, the Washington casts a longer shadow. So this guy's got a shadow, we'll just call it, that's what the shadow looks like, 0.7, but the obelisk has a shadow, or the monument has a shadow of 65.8. How tall is the Washington Monument? X. Well, we can see we kind of have like a proportion for us to set up, right? We have maybe, we could say like height next to, I don't know, shadow or something like that. I think I spelled that wrong with height, but oh well. So we're going to put the real height, so 1.8 to the shadow height, 0.7. Real height of the obelisk or Washington Monument, x to 65.8. And then we just cross multiply, so we get 0.7 x equals 1.8 times 65.8, which is a big fat decimal number. And then we just divide by 0.7, and we get 169.2, and that's going to be meters. So yeah, there we go. All right. Getting close to the end. Determine if the triangles are similar. All right, so remember we have side, 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 angle, angle, and side, angle, side. Okay, so this one could only be SAS because I only have two sides. I have the vertical angles, so I have to check, are these proportional? So I'm going to take the smallest side, which is 12, and I'm going to compare it to the smallest side, which is 16. So in this one, these should line up. And then I'm going to take the largest side, 15, and line it up with the largest side, 24. Are those the same? And so when I reduce them, I get 3 over 4. And when I reduce this one, I get 5 over 8. Those are not the same, so I'm going to say not similar. Doesn't work. Okay, next one, I don't have any side numbers, so it can't be either of these two. So it has to be angle, angle, or it's nothing. And so I see the vertical angles, and I see, of course, alternate interior angles, so it's definitely angle, angle similarity. P is going to match up with F, A is going to match up with A, and S is going to match up with C. I only see sides, so this has to be side, 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 or it's nothing. Again, I'm going to take the smallest side, which is 8, and put it over the smallest side, which is 10. Next small size is 9 over 11.25, and then 12 over 15. So this should reduce down to 4 over 5 pretty easily. That one also I can do in my head. Those both divide by 3, 4 over 5. 9 over 11.25 also divides the 4 by 5. So this is side, side, side similarity. Now I'm going to use colors to help me. 8 and 9 are the smallest sides, so I'm going to color that D. The two smallest sides are matched right there with C. So I know those are going to line up. And then I'm going to go between the small and the large side, which is B, small, and the large side is A. So that's going to help me when I write my similarity statement. So A matches up with R, D matches up with C, and then the only one left is B. So it should be RCB. All right, here I see sides, but there's a shared angle here, so I'm thinking it could be SAS. I don't have a third side, so it can't be side, side, side. And I don't see parallel lines, so it can't be angle, angle. So it's got to be SAS or nothing. So what we're going to do is, first of all, I got to find this length here, which is 45 minus 9. So we get 36. So I'm going to go 32 over the whole thing, which is 40, equals 36 over the whole thing, which is 45. Are those the same? And they reduce to 4 over 5, and this reduces to 4 over 5. So we do have SAS with that included angle right there. A is going to match up with B, C with C, and D with E. And this one, if you can't get this one right, I don't know what I can do as a teacher, but that's angle, angle. And then match up the angles. X matches with E, Y matches with N, and Z matches with W. Okay, that one was, I'll do that one all day long. All right, set up proportion time. So as long as you're consistent, you're going to be awesome. So I'm going to go top to bottom, because it already kind of looks like it's in a proportion. We can simplify these or just straight multiply across. I'm going to be lazy and just multiply across. I have my calculator anyways, and then divide by 8. X equals 18, right? So not too bad. Again, same thing. Set up a proportion, be consistent. So you can go, here to here, here to here. I can go here to here, here to here. Really, however I want to do it. I'm going to go 7x minus 1 to 22. So I'm going like big piece to small piece, and then I'm going to do the same thing. 3x plus 1 over 10. I'm going to cross multiply to get 70x minus 10, and that's going to be 66x plus 22. I'm going to subtract the 66x to get 4x, add the 10 over here to get 32, and 32 divided by 4 is going to give me 8. Okay, so this one is a little bit trickier. Since I don't have this piece, it might be easier just to add these together, 8 and 12, which makes 20. And so what I'm going to do is I'm going to go x to 8. So I'm going to go bottom to top, which might be confusing. Maybe, well, whatever, I'll keep it. I'm going to go 24, the whole thing, to the whole thing up here, 20. Cross multiply, we get 20x equals 8 times 24, 192, divide by 20, and I get x equals 9.6. And again, decimals are okay. Don't fear, the decimals are here. Find the perimeter. Well, pretty easy when you have this number. These guys are going to be a 2-to-1 ratio. So if that's 41, this must be 82. That's 38. This must be 76. Now, the only one I don't know is that, so I have to solve for that. So if I double the small guy, which is 4x plus 1, and set it equal to 11x minus 25, I need water. I need water. I think this is a good time. On the test, the written portion, at the very top, if you draw a Christmas tree, I'll give you extra credit. Okay. You didn't hear it from me. 8x plus 2 equals 11x minus 25. Subtract the 8x, add the 25, divide by 3, you get 9. And then plug 9 back in here, so 11 times 9 minus 25. That's going to be 99 minus 25, which gives me 74. So I'm going to add all 4 of those together. 74 plus 76 plus 82 is 232. It didn't give me units, so that's all I got. All right, the back should be factoring, which I love factoring. So, all right, here we go. Negative 60 and negative 7, not too bad. Negative 60, what multiplies to negative 60 adds to negative 70? Again, you just kind of go through 60 and try different values, right? I'm going to try 4. 4 and 15 would make 11 or 19. That doesn't work. We can try 6 and 10. That's not going to work. Let's try 3. That was not how I meant to do that. 3 and 20. No. Let's try 5 and 12. There we go. That would be it. 5 and 12. And the 12 is going to be negative, so I get negative 7 when I add it. And so we get, x plus 5 and x minus 12 equals 0. Since you're going to set them both equal to 0, you're basically going to get the opposite of what you see on these. So you're going to get negative 5 and positive 12. This one we just got to move the 36 over. So we get something that looks like this. I was asked to show split the middle term, I think. I would divide by 2 and then you don't have to split the middle term. So yeah, I'm not going to do split the middle term because it's actually not the right way to do it. So I'm going to divide by 2, and then I'm going to go ahead and multiply to 18, what gives me 9. What two numbers multiply to 18, but adds to 9? I'm thinking 6 and 3 right there. So we get x plus 3 and x plus 6 with a 2 over here and a 0. The 2 is kind of arbitrary because I could divide the 2 out and it would just kind of disappear. So I just really set these equal to 0 again, which is going to give me the opposite values. And then last one, I want to rationalize, so I'm going to multiply rad 6 because I can't have rad 6 on the bottom. That's going to end up with 3 rad 6, and then that's going to be 2 times 6, which is going to be 3 rad 6 over 12. But the 3 and the 12 can reduce to rad 6 over 4. And that I can have as an answer. All right, team, that was it. Now my voice is gone, so that's cool. Have a good summer. Hope you enjoyed the video.